So what we're going to do today, like I said, on section 1.6, is we're going to look at both homeworks 14 and 15, even though we started this on Friday. We're going to look at some of the details of some of the specific problems, so hopefully this will help out with all of this. So here's basically what I want to do. I'm going to go over these problems right here, because if you can understand those, you can do everything that we talked about on Friday. So I'm just going to go right to it, and let's make sure we can kind of understand what's going on. All right, so what's going to happen is they're going to give you a function like x squared. And the question is, find f inverse of x if possible. Okay? All right. So we want to find the inverse function if it's possible. So what you do first on every single problem is you figure out, is it or is it not 1-to-1? Okay. All right. So what's one way that we have of doing that? Graphing it. Okay. So that's the way we're going to do it today. We're going to always check it by graphing it today. But tomorrow, we are going to learn that there is a non-calculator way of checking to see if it's 1-to-1 or not. And there's a way to do it algebraically. And I'll show you that tomorrow. So we're going to, do we even need a calculator to do x squared though? No. So we're going to check, is it or is it not 1-to-1? So we're going to graph x squared, and what about it? It's not. So what you would say is f is not 1-to-1 because f fails what? Horizontal line test, right? And then what does that tell you? Doesn't have an inverse function, right? So f does not have an inverse function. Yep. And the reason why is because it's not good enough in math from this point on to just give me an answer. You have to tell me why. You have to justify it. And I know that's going to get hard to get used to, but you just got to start doing it. Okay? So guess what? You're done. Those are the problems you want. If it's not 1-to-1, you write that little sentence, you're done. You don't have to do anything. Okay? All right. So, and on the homework and on the test, you will have problems like that sometimes where it's not 1-to-1, no inverse function, you're done. So obviously we want to work some problems then that do have inverse functions, because those are the hard ones. Yeah, you do. Yeah, you do. Okay, so let's do an Algebra 1 problem then. Okay, so the Algebra 1 problem with this is when it's linear. So let's do a linear one like 5x minus 7 divided by 3. And we want to find the inverse function. Okay, so this is something that used to be in Algebra 1 books. I will be honest, I don't think in your Algebra 1 book, it did have inverse functions because I taught it last year, but I don't think it ever actually had them find it for a linear function. I think they waited and had y'all do this in Algebra 2. But this is something that used to in Algebra 1 books, it would make the kids do because it's not that hard. But first, we still have to check, is it 1-to-1? I think. Straight line, positive slope. You don't need to graph it. Yes, right? We don't have to do a perfect graph. What's the slope of that thing? Over 3. So you know it's got positive slope going uphill. You know it's 1 to 1. We don't have to graph it. So we just make our little sentence. So the A part is F is 1 to 1 since F passes horizontal line test. Thus, F has an inverse function. Therefore, thus, so, hence. Sure. I mean, it gets boring to use the same word time after time after time, so yeah, I do that. No, I don't think that would work. So now this one has then a B part, and that is we have to actually find the inverse function. So this is something that, here again, in Algebra 1, that used to they would have asked students to do. But here's what you got to do now. Now, there's 2 ways to do this. I'm going to have you do it slightly different than the way you were taught last year. It's really the same, but there's a reason why I'm going to have you do it my way. Okay, so just, I don't want to have to unteach you, but I kind of am. So here's what Miss West would have taught you to do. She would have said, where it says f of x, yeah, yeah. So step 1's going to be um, change f of x with y. So in case there's not a y, go ahead and put it there because we know f of x and y is the same thing. Now here's what Miss West would have taught y'all to do last year, and it's not wrong, but she would have said switch the x's and y's, solve for y. Okay? That's what she would have taught you. Okay, I want you to do it a little differently because there's a reason for in calculus. But what I'm going to tell you right here is solve for x. So I need to get this variable by itself. So how would I get rid of those numbers? What would I do first? Multiply by 3. Excellent. 3's cancel on the right. Okay, then what? Add 7. Excellent. Take that negative 7, move it over. Comes a positive 7. Okay, then what? Divide by 5. Get x. Now, what you have just found is the inverse function. F inverse of y is 3y plus 7 over 5. Now, if they would let you leave the answer like this, inverse functions and why we need them would make perfect sense. Because here is the purpose of an inverse function. I mean, this is the reason we do these things in the first place. Sometimes you have equations, and this function might mean anything, but let's say we plugged in, I don't know, 10. So if I plug in 10 into this equation, I get 15 minus 7 is 8, and I get 8/3, right? Sometimes you know the x and you want to figure the y value out. But there are other times when I know what the y value is, or I know what f of x is. And I would like to figure out, if I know the y value, I want to know what the x value is. Well, if we had a whole bunch of these that we wanted, let's say we had y was 8/3 and 10 or 2 and 7 and 20. We knew all these y values and we wanted the x. Well, I don't think any of us would want to do this right here. I don't think any of us would want to say, okay, 10 equals 5x minus 7 over 3. Or say 8/3 equals 5x minus 7 over 3. I mean, I don't think any of us would want to solve equation after equation after equation after equation. So what we do instead is, if we knew the inverse function, we would plug in the y and get the x value. All right? So what am I getting at here? Okay, so write this down. When you have a regular function, you plug in or substitute an x, you get a y value. But when you have an inverse function, what you're really doing is you're plugging in a y value and you're getting the x value. That's really what you're doing. And that would make perfect sense if I could write my answer like this. And in calculus, we do sometimes. But you know, when you graph stuff on graph paper, or even on our calculators, will they let you say, 3y plus 7 over 5? Can you type that in your 84s or your Inspires? No. You got to type x's, don't you? So for us to be able to graph it on graph paper, what they'll do is they'll switch those y's to x's, and they'll say, well, this is the inverse function. It's just so we can graph it. But the thing that's confusing, you see x's there, don't you? But what you've got to realize on an inverse function is what you're really doing is, if you have this original function, if you plug in the y value for that original function, you're going to get the x of the original function. Like you see this problem I did right here. When I plugged 10 into my original function, I got 8/3, right? So if I were to plug in 8/3 into the inverse function, what should I get? 10. And I did do my math there, didn't I? What did I do? That's 3. Oh, it's divided by... Hold it. What did I do? Well, it would help if I would have plugged in the right number, because should have been f of 3. Okay, all right. See, it was f of 3. I did it right. Okay. Yeah, 5 times 10 is 50, not 15. So I really did. I did what I really meant to do. Okay, I meant to do that. So, f of 3, and we get 3, right? So basically, what is happening is, and you don't have to do this, but on my original function, f of 3 was 8/3. So what happens on the inverse function is, if you plug in 8/3, the answer you get on the inverse function is 3. This is really a y, and that's the x. And it would make so much sense if they'd let you write it as f inverse of y equals whatever, but they don't. But I want you to do it on the homework and all, and on the test, so that this makes more sense why we're doing this in the first place. Now that right there is the easiest problem I can give you. If it's linear, that's really an Algebra 1 problem. So everybody's got to know how to do that one. Everybody. Now, keep in mind, all this other stuff I did here, I mean, this is just to show you what it's doing. As far as the problem is concerned, I would have been done right here. Okay? Say that one more time. Oh, it is. These problems we're going over, it's going to say find the inverse function. No, 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 no. That's how you have to do it. Yes. Yes, you must do that. So let's bump it up a notch then and do some that are a little bit harder. Here's one like 45. Okay, will y'all graph that on your calculator? So this one's a little bit harder, right? Or is it? Okay, so tell me what you write. Oh, so it's not harder, right? It looks harder, right? It had a fraction. Had x's in the bottom. So tell me what you write. F is not 1-to-1. Not it, not use pronouns. F. Okay, one more sentence. F does not. Right. No. No. All right, good. Now, seriously, y'all, on the homeworks, you gotta check this because you may get a problem and you'll do all this algebra work, and if you don't graph it and see if it's 1-to-1, you've done it for nothing. All right, so always check the 1-to-1. So we're done, right? Nothing. I don't have to do anything else. All right, so I'm just telling you up front, two of your three first homework problems are like this, where they're not 1-to-1. Okay, we're going back. So that's 41 through 45 odds. So now I need to go over 53 and 55. Whoops, there we go. All right, so let's do one like 53 now. Oh, you can, here. Well, it's fine. It's fine. You got to realize though, I was taught in the era where we were told that we could never, ever, ever put contractions in papers. Yeah, we could never, and we couldn't use you or I in our papers. We couldn't. We would have to say the writer believes that. It is the opinion of this writer that. That's how we had to do for the I. It's the opinion of this writer that. So. Okay, 53 and 55 then. So let's see if you can do 53 for me. So here's the function. Okay, so I'll do it. Okay, so he has if it's 1-to-1, it passes I. What is this mistake? Okay, not vertical line test, right? Horizontal. Okay, so that'd be a mistake. All right, so then it looks like you added 7 divided by 8. So this is really if inverse of y. Here again, if we could write it like that, it would make so much more sense because you would understand, hey, I'm plugging a y value from the original function and I'm getting what? X value, right? You're really plugging in a y value from the original and you're getting the x of the original. But in order to graph it or do anything, you have to put this with this into the answer. You're switching all the y's to x's just to graph. And see, to me, if that final answer, even though this is the accepted answer, it doesn't really tell you what's going on. That's why I want y'all to do this step. This will help you know what you're doing. Because this would be so much easier if I go to try it like this. But this is the accepted answer. Okay, make sense? Got it? Okay, we're going to try one more. See if you can write this one up. And then okay, here is one like 55 then. X to the fifth. See what you can do with it. See what we got. Yep. So G is 1 to 1. Since G passes the horizontal line test, therefore it has an inverse function. So you notice all he did is he just didn't get it through. Right? Okay. And that's it. Okay. So we've learned 2 out of the 3 kinds of inverse function problems. The easiest one is when. Not 1 to 1, doesn't have one, right? That's the easiest one. Then the ones that are almost as easy but kind of basic are things like this, when they're linear, it's really easy to solve. Tomorrow we'll get to the hard ones, where there's domain problems. That's where it gets tricky. Those are the hard ones.